Okay, I'm going to show you how to switch from log to exponential and exponential to log, and then how to evaluate with a calculator and without a calculator. Okay, so if we have, well, let's just do this definition. So if we have b to the x equals a, this turns into log base b of a equals x. Okay, this is our definition for a log. So just like we can undo a square root by doing squaring it, or I can undo adding by subtracting, or I can undo the cube root by cubing it, or I can undo multiplying by dividing, okay, we can undo an exponential by taking the log. So let's take one that we know, like say 2 cubed. So that's 2 times 2 times 2, which gives us 8. Okay. So this is a true statement. So if I wanted to switch it to log, notice the base went here, and we say this log base b of a equals x. Okay. Notice this is a subscript, and my log a and x are all like on the same line, and the b is below it. Okay. So the base was the same for here and here. When you say this log base b, it helps you remember that it's the base. So I'm going to do log base 2, and then we're going to hop to the other side, right? It's because we had a, and a was on the other side. So log base 2 of 8, and then we're going to hop back to the other side equals 3. So you've got this little like hopping around the equals sign to go from log to exponential. So if I had 4 squared equals 16, this would turn into log base 4, hop to the other side of 16, hop back to the other side, so equals 2. Okay. If I gave you 7 to the 17th equals x, to switch this to log, I would do log. The base is 7. I know the base is 7 because it's what has the exponent, so I'm going to do log base 7, hop to the other side of x, hop back to the other side, equals 17. Okay, let's try a few more. So if I have 12 to the 1/2 equals p, the base is 12 because that's what has the exponent, so I'm going to have log base 12, hop to the other side of p, hop back to the other side, equals 1/2. Okay. Now we have a special base where we drop the base that we write. So if I have 10 cubed equals 1,000, okay, instead of writing log base 10 of 1,000 equals 3, we just end up dropping the 10. So that it's just log 1,000 equals 3. So if I give you 10 to the 4.6 equals z, I would have log z equals 4.6. Okay, we have one other special one. It has to do with a special number that's similar to pi in that it goes on for forever, and we use a letter to describe it. So we have this letter E that stands for the number 2.718281828, and it keeps going. It looks like it's going to repeat itself, but it stops repeating itself as you go on further. Okay, so this is our number E. Okay, it represents the growth rate of something that's continuously growing. So when I have this one, we have a special one that it turns into. So log base E turns into what we call natural log, which we use ln to represent. So it could be in cursive, or you could have it just written out. So ln like this or ln like that. So if I had e to the second equals p, then I would do the natural log, because instead of log base e, I'm going to write natural log of p equals 2. Okay. If we have e to the x equals 1208. When I switch this, it's going to be log base e, which I'm going to write as natural log of 1208, then hop back to the other side equals x. Now we can go the other direction as well, and if I have a log, I can go back to an exponential. So if I have log base 4 of 602 equals p, here I'm going to start with the base, so I'm going to start with the subscript. So I'm going to do 4, then I'm going to hop to the other side, so to the p, and then hop back, equals 602. Okay? So notice it was in log form, and now it's in exponential form. Okay? Log and exponential undo each other. Okay? This would be like the square root versus squaring it, or adding versus subtracting. They're inverses of each other, and they undo each other. So if I give you log base 9 of 1797, okay, equals q, this would be 9 to the q equals 1797. Okay? We started with the base, hopped to the other side, hopped back. Okay? Now, if I give you something like log base 2 of 64 equals m, I'm going to have, start with the base, so 2, hop to the other side, to the m, hop back to the other side, equals 64. Okay? Now, we can use this definition of log to help us evaluate some logs. So if I give you log base 3 of 27, and I say to evaluate without a calculator, what you're going to look at is you're going to switch it so that it's exponential. So I'm thinking to myself, log base 3 of 27 equals what? So I'm going to switch forms. So I have 3 to the what equals 27. So 3 to the what equals 27. Well, if I start thinking about the powers of 3, I'm going to do 3 times 3, which is 9, and then I'm going to times by 3 again, which gets us to 27. So really, 3 cubed is 27, which means that log base 3 of 27 is 3. Okay? So that's how we figure out the answer without a calculator. Okay? Let's try another one. If I have log base 5 of 625, it'll come without the equal sign. So if I want to evaluate this, I'm going to think 5 to what power gives me 625? So I'm going to start with my powers of 5. So I'm going to do 5 times 5, which is 25. If I do 25 times 5, I get 125. If I check to see what 125 times 5 is, that gives us 625. So really 5 to the 4th is 625. So that means that log base 5 of 625 is 4. Okay. Now, if I have one that is log base 16 equals 4, I'm going to think of 16 to what power equals 4. Okay. Well, remember that, no, I'm not going to have you do that one. I lied. I do want you to have, let's do this one. Log base 2 of 1/8. Okay. So I'm going to think 2 to what power gives me 1/8. So if I want to find out what power of 2 gets me to 1/8, remember that I could write, well, let's just look at the bottom part. So if we do 2 times 2, that gives me 4 times 2, which is 8. So 2 cubed is 8. So I have 2 to what power equals 1 over 2 cubed. But remember, if you want this out of the denominator, you can move it to the top, but change the exponent to a negative. So I have 2 to what power equals 2 to the negative 3. So anytime that you end up with a fraction, your power is going to be negative. So this gives us negative 3. Okay? Now, there are times when you won't be able to figure it out just by hand. So if I give you log base 5 of 700. Okay, well, if we do 5 times 5, well, first I'm thinking 5 to the what gives us 700. Okay, so 5 times 5 is 25. 25 times 5 is 125. And then 125 times 5 is 625. Oh, whoops. 625. And then if I do 625 times 5, that gives me 3125. So 5 to the 4th is 625, but 5 to the 5th is 3125. So can you see that 700 fits in between these two numbers? So I know that my power is going to be somewhere in between 4 and 5. I just am not sure. Now I could sit and check and do like 5 to the 4.1, 5 to the 4.2, 5 to the 4.3, but that's annoying, right? So what we've done is we've found a way that we can put it in the calculator. Now your calculator runs in base 10, so in order to put that into your calculator, let's see here, I think it was log base 5 of 700. I don't know why I erased it. In order to put this into the calculator, what I'm going to do is I'm going to do log 700 divided by log 5. So I do the of part divided by log of the base. Okay? And that's how I put it into the calculator. So if you go log is left of number 7, so if I put log and then I do 700 and then close my parenthesis, please make sure you close that parenthesis, otherwise it will give you the wrong answer. I'm going to do divided by log and then the base, which was 5. So then I hit enter and we get 4.0704. Okay. Now, there's a second way if you have the 84s that you can put the logs in. So if I hit math, if you hit up, letter A says log base. So if I hit enter on log base, notice it gives you two boxes so that it looks like this problem right here. So I'm just going to put 5 as the base, and then I'm going to hit over and then hit 700. So I get 4.0704, which is what we got the first way. So you can do it either way in the calculator, both which give you the same answer. Okay? So that's what I'm going to do for the calculator. Now, if I have one that's already in base 10, so say I give you log 6059, okay, the log is left of number 7, so I can just do log and then put in my number, so 6059, and then close your parenthesis. You don't have to close the parenthesis on that one because you're not doing any operation after it, whereas on the first one up here, we had to close the parenthesis because we were going to divide by another log. So that gives me 3.7824. Now, we also have the natural log on your calculator. The natural log is left of number 4. So if I wanted to find the natural log of 16.2, the natural log of 16.2 I just put in as the natural log of 16.2. So for log base 10 and for the natural log, it goes into your calculator just like it looks like. For any other log, you're going to take the log of the one that's in line with the log over the log of the base. Unless you have the 84 where you can do math and then go up to log base and then make it look like your paper does. Okay, so that's how you can evaluate without the calculator for ones that are nice. You can evaluate with the calculator and you switch between log and exponential.